You are listening to a Sustainable World Radio podcast. Sustainable World Radio brings you in-depth interviews, news, and commentary about exciting, creative, and innovative ways of living. Produced in Santa Barbara, California, Sustainable World focuses on positive solutions to environmental challenges, solutions that adhere to the permaculture ethics, earth care, people care, fair share. Are you interested in learning more about permaculture projects around the globe, how to plant a food forest, restorative design, or ethnobotany? Then stay tuned to Sustainable World Radio. I'm Jill Cloutier. This is part 2 of a 2-part Sustainable World Radio interview with Doug Weatherbee, the soil doctor. Do you have a list of plants that say that you are growing broccoli and cabbage, what they would like? And then is that too advanced for the home gardener, or do you think that's going to be something that people will be doing more in the future or are already doing now?
Well, Pete, there are a lot of growers that are doing this around the world, and more people are doing this even in their home gardens. Certainly all the landscape people are doing it. There's a lot of knowledge that Dr. Ingham and the labs and other folks have been able to create for the last 20 years, which allow us to start pinpointing approximately what that range, that ratio should be for different plant groups. So yeah, short answer is you can say, okay, if I want to grow broccoli versus tomato versus grapes, those are 3 different fungi-bacteria ratios that each one needs. Right? Turns out we need slightly more bacterial-dominated soil for broccoli. We need almost an even mix for the tomatoes, and we need much more fungi-dominated soil for the grapes. And so then you can look at what am I putting into my system, right? It's not just that I'm trying to feed the plants. I'm actually feeding the microbes in the soil, but which microbes in the soil am I feeding, right? And if I'm creating my own compost, the same kind of thing applies. If I build a compost that has tons and tons of manure in it, I'm exaggerating here a bit, but we know manure is a bacterial food versus, let's say, the wood chips that you mentioned a minute ago, a mulch. So I can when I play around with the starting materials of my compost, the more richer nitrogen stuff I put in there, the more bacteria I'm going to have at the end of the day. And so if I put slightly less bacterial food inputs into my compost, slightly less manure, slightly less alfalfa, things like that, and I have more longer-term woody material in there, and I let my compost rest in a moist condition for a few months, I'm going to start growing a more fungal-dominated compost. And that compost, if I put it out into a bacterial-dominated soil, is going to nudge that soil from a bacterial-dominated situation to a much more vibrant fungal biomass community more quickly than if I didn't do that.
What you're doing then is farming microbes,
yes,
and feeding the microbes. In turn, they feed the plants.
Yes,
is very simplified.
That's exactly it. Partnering and farming with what's in the soil.
But so bacteria like simple sugars, and more of a carbon-based, maybe woody thing for the fungi.
Yep.
How do you, so you fine-tune your compost to feed fungi or bacteria. Are
Yep.
there any other ways besides compost to, have these populations thrive on your land?
Sure, and this sort of gets into, okay, like if I work with farmers where, we're doing broad acre stuff, where we've got hundreds and hundreds, thousands of acres of stuff. Putting out compost is like, wow, that's a lot of work, putting out that much compost. So what we might want to do then is say, well, okay, what if we were able to put out still a whole bunch of good guys, either fungi or bacterial-dominated, let's say, in that population of good guys we put out. If we could take that compost and then extract off the microbes that are living in that compost, whether it's fungi or bacterial-dominated, extract them out into a solution, into a water solution. And then if I was able to, when I extract that out, keep that water solution aerobic, because remember, I want to grow as many good guys as possible. And when I say grow, I mean, okay, so if I start out with a fungal-dominated compost, and what I want to have is a fungal-dominated water solution, then I'm going to put some fungal foods into that water solution with all kinds of bubbles. Think a giant fish tank with like on overdrive with a bubbler. And I'm going to let the microbes, the fungi and the bacteria that I put into this solution off of that original compost, I'm going to let them gnaw on all this food that I put in, let's say over a 24-hour period. But because I've only put in mainly fungal foods, I'm going to try to rapidly grow the fungi versus the bacteria, and then take that solution out into my field and apply that to the soil or do foliar sprays to the plants, etc. And now I'm bringing all kinds of good guys out into my fields right there.
Which is compost tea.
That's exactly it. That is exactly what compost tea is. And there's another discussion people are talking about, like compost extracts, which are actually sometimes easier for people. And an extract is really saying, rather than taking all those critters off of the compost in the water solution and then trying to grow them for 24 hours, let's say I just was able to shake them all off the compost into the water and then don't put any foods in to make them grow, and that might take me 2, 3, 4 hours to shake them off into the water and then immediately go out with them. Okay? Now, I'm going to need more compost to do that. That's called an extract. I'm going to need more compost to do that. But what I do is save in some time. And I may not necessarily get the same numbers that I would get if I grow them over 24 hours, but it's certainly a bit easier, right, in terms of time to be able to get out there within, let's say, 2 to 4 hours versus 24 to 30 hours with a tea production.
That makes sense.
Right.
So that, and the compost tea would go a lot further on your land by spraying the liquid than having to apply compost.
Exactly. But the difference, what you have is you still, compost tea is really just bringing a whole bunch of good guys to the soil party, let's call it.
The pool party.
Yeah, the pool, exactly. And so what we really have there is we think of the compost tea and the extract as an inoculum. But when you look at compost, it's both good compost, aerobic compost, the way I've described it, is both an inoculum and it's a whole bunch of organic matter that's a food for the microbes and eventually, because of the nutrient cycling, for our plants, that's going to be there available for, it depends on how much we put out, 1 year, 2 years, 3 years, right? Whereas, again, getting back to the compost tea, I'm not putting out that organic material. So I have less, if you will, nutrients going out. I have the nutrients in the bodies of the good guys that I'm sending out, but I don't have more food for them to keep growing and eating off of for the next little while. So that's really the difference. So if you get into compost teas, you'll see that the application rates of compost teas, depending on how bad the soil is and where you want it to go, could be, even starting off, could be every 2 weeks, maybe going to a month, maybe in a month and a half, 2 months, depending on the health of the soil again. Versus the compost, you might apply, once a growing season, once every 2 growing seasons, maybe even 3, depending on how healthy your soil is, and if you combine it with, let's call it rotational cover crop cocktails and other things like that. So it really depends on individual situations and so forth as to whether you do both compost tea, or you just look at compost teas, etc.
I love the idea of the cocktails and the pool party. It sounds so much more exciting than spewing Roundup all over. This is adding fun to.
Yeah. Bit of a downer for the party sometimes to have the Roundup.
Well, that does bring us to that idea of how people say it takes thousands of years or hundreds of years to build new topsoil. So basically, getting back to the Roundup idea, by spewing all of these chemicals on the soil, we've really depleted those microbial life in the soil. But it sounds to me, Doug, that you are actually, by building the life in the soil, you're contributing to soil fertility. And have you had results in improving and actually building topsoil using these methods?
I think I'm answering yes to both. Is a short answer. And I think what I would say is that when people talk about how long it takes to build soil, and I think the question might not be how long does it take, but what does it take? Who builds the soil? Soil is an synergistic ecosystem that has to do with the life in the soil. And when I mean the life in the soil, I mean the microbes in the soil partnering with the solar harvesting plants, right? And the ability for us to build topsoil is really the ability for us to build soil organic matter, which is really carbon. So we need the ability of those plants to pull the carbon, fix it, if you will, into their bodies and excrete it into the soil. And we need the ability of the microbes to be able to gnaw and chew away at all that dead plant residue that's either going to drop as a litter on the top of the soil or is going to actually be roots that get sloughed off and the plant dies or it gets cut, whatever, all that underground stuff, all that organic material, some of it, well, a good chunk of it from the microbial standpoint is going to actually be oxidized. It's going to be pushed out into the atmosphere as CO2, and that's part of the natural carbon cycle of the planet, is the ability of plants to fix that carbon, the ability of microbes, if you will, to take that carbon and release it back to the atmosphere, right? So it's a big, giant cycle. But if we have enough carbon being fixed into our system, and when I say enough carbon, I mean in relation to sort of nitrogen here, and this is a bigger discussion that I probably can't go too deep into here, but just like in our compost piles, if I put a lot of nitrogen in a compost pile, I'm feeding a lot of bacteria. And remember I talked about how things can start going anaerobic, and then you get that ammonium smell, and boof, things are starting to go up into the air, and all of a sudden your big giant compost pile is like 40% of its original size. How did it disappear? It's because most of it went into a gas. Well, that can happen in our soils as well. And so what we need to do is start thinking about how to manage carbon residues, carbon cover crops, let's call them, that are constantly photosynthesizing, producing organic plant matter mass, enough of which that is going to feed the microbes, is going to participate in that global carbon cycle, but there's going to be, as a side benefit, a net gain of the soil organic material, the carbon being fixed into the soil in the form of, organic material, like I said, humus, the soil, glomalin, a byproduct of mycorrhizal fungi. All these substances are high in carbon and very stable, and they're byproducts of this global nitrogen cycle. Right? So building soil, the only way soil can be built is through that process, right? And it's the diversity of microbes in that system, the ability for us to have plant cover above ground, the photosynthesizers, and to not be, if you will, destroying the fertility of the soil, destroying or breaking up the aggregates of the soil, which contain all that organic matter and so forth. Once we start doing that, we're actually sort of homogenizing the soil, and we're bringing all that carbon into close contact with folks who want to eat it, burn it up, and send it back into the atmosphere as CO2. So we're losing carbon, we're losing topsoil, okay, as we do these practices, rather than creating it like some of those natural practices that I described. Can we do this in our agricultural fields? Absolutely. Have I done it? Absolutely. You can do this within a growing season. You can see results. I talked with an interesting chap just a few weeks ago, actually, in Australia, as a cattle rancher, and he was telling me about his experiences of using Compost Tea, where he had created a control plot and a trial plot, and it was a pasture, and so he was doing set stock rates in both sort of plots or paddocks with cattle, meaning he had a certain number in each, and he went into one and did a compost tea spray down, fungal dominated with fungal foods, and he described to me, he said, I'd go out there within a couple of days, it was almost like I was seeing the grass in this compost tea one grow before my very eyes. And he just started to see this incredible ability of this particular paddock to support his cattle, meaning that he could put more calves who were really hungry and looking for weight gain into that compost tea paddock. And he said it was like amazing the results that I was getting, and he had to give a talk. So he went and got the nutrients tested in the soil, and he ended up building a couple of percentage points of organic matter in a 12-month period with this tea, over the control side. So he went from, I think he had pretty good levels. He had something like 6%, which was pretty high for carbon in these when he started, and he went up a few percentage points in that 12-month period. And I've seen results here in Mexico doing this with corn, where you can visibly see the aggregates, the structure of the soil becomes more crumb-like, cake crumb-like, if that makes sense, where you pick up the soil and it's like these big crumbs from a cake.
Mm-hmm, kind of fluffy and spongy and light.
Yeah, and that is a direct product of the microbial activity in the soil, creating a whole bunch of carbon, if you will, embedded into that soil in all these little microscopic caves that are in there. And so, yeah, you can build, we have examples of this all over the world now, where people are building, reversing the trend of lowering the carbon in their soil, reversing that, and actually building carbon.
And does this building of carbon, do these microscopic beings, can they actually help possibly be a solution or one of the solutions to help mitigate climate change by pulling excess carbon dioxide out of the atmosphere?
Absolutely. I just actually did a symposium at a fantastic conference a few weeks back in Albuquerque called the Carbon Ranch, put on by the Quivera Coalition. And I would encourage folks out there, if they get a chance to go to this conference in any future years, it's probably one of the best conferences I've ever been to. And there were folks all over the world. I was presenting on the microbiology. There were folks, Rodale, Jeff Moore was presenting on no-till agriculture. We had Greg Judy presenting on mob grazing and holistic management. All these different techniques are building carbon in the soil, increasing the amount of soil organic matter, and people were there to talk about really carbon sequestration in soils. And in some ways, it's the most cost-effective way for us to do that, is to actually start building our soils back up, increasing that soil organic matter. And the central key way that we need to start thinking about doing that is partnering with the microbes in the soil, creating the conditions in the soil which are going to give rise to the production of things like humus, glomalin, all this kind of stuff, which are the stable forms of carbon in the soil. And the only way that gets done is through the microbes. And as we move from a bacterial-dominated soil into a more fungal-dominated soil, I mean, any of us that go into an old-growth forest can see that there's a heck of a lot of carbon in that soil, right? If I go to a desert system and I look around, wow, there's not a lot of carbon. Now, I'm, using an extreme here. One is wet and one is dry. But we can physically see the differences in those soils. And if we think about moving across that continuum, that succession continuum, the way that we start building some of that structure in the soil, bigger and bigger aggregates, bigger and bigger kind of microscopic caves in the soil with more and more ability to sort of hide and tuck away a little bit of humus there and a little bit of glomalin there and all these different things from particularly the bacteria that want to take that, eat it, and chew it up and send it up into the atmosphere as CO2, the more carbon we're going to build into that soil.
And does the carbon escape from the soil when the land is tilled, or if those microbes die? What do you do in that?
Well, that's why I think, there's some really, so the short answer to that is, every time you till, you've got to blow off of carbon, because what you're first doing is you're taking that structure in the soil, the heterogeneity of the soil. If I move 1 millimeter in the soil from one location to another, that's like a completely different soil from a microbial standpoint. That's like going from here to China. So the ability of things to be, I want to say, hidden from those who could eat them and produce CO2, if you have a really diverse, well-structured soil like that, there's going to be more and more nooks and crannies where all that carbon can exist without necessarily being chewed up and blown off into the big global carbon cycle. And so when you come along with a plow or a rototiller at home, or if you double dig your garden, I mean, all these things are breaking up all that soil structure, killing all that fungi. And fungi have a pretty decent amount of carbon in their bodies. And now what has just happened? Well, those guys are dead, and other guys are going to come along, usually bacteria that are going to eat them, blow them off as CO2. So all of these things are creating conditions for the blow-off, the release of carbon from our soils.
Can soil become saturated with carbon to where it can't hold anymore, or does that not happen?
Well, you got peats up in the north, which are pretty intense in terms of the amount of carbon that they're in there. And I guess the question is, I don't think we're going to have that problem in most of our agricultural soils where we're going to reach an upper threshold. Now, a traditional agronomist in traditional labs would say that, you need 1, maybe 2% organic matter in your soil in order to have good growing conditions. But what we have from around the world is a lot of sort of historical data. There was some interesting stuff at the conference a couple of weeks ago presented about a man who traveled in Australia a few hundred years ago, who originally sort of pegged some of the soils there to have, between 22 and 24%. And there's some documentation that comes out of New England which points to about 20% of, and so you talk to a traditional agronomist and they might say that you can't grow stuff in that. That's too high, right? And what we're seeing over and over again is that there are huge benefits to increasing the organic matter in your soil, a lot of which I've been talking about, that is really an increase in the fertility of that soil. It's the ability of that soil to feed your plants above ground.
And by increasing organic matter in the soil, for listeners who may not know, doesn't organic matter just refer to living things or things that used to be alive?
Well, by that I mean stuff that contains carbon.
Mm-hmm.
And that can be dead and that can be alive. And it's a good point because one of the things that people sort of overlook, I think, is the amount of carbon that's physically in the bodies of the microbes in your soil. And I did some calculations. Actually, you're sort of reminding me of this. I did some calculations for this presentation a few weeks ago. See if I can find them, which I thought was pretty amazing. I worked with Matt Slaughter at the SFI lab, the Soil Food Web lab in Oregon, to come up with the way to calculate this. Because one of the things they do there is they measure the amount of biomass of bacteria and fungi and the numbers of amoeba and flagellates and ciliates and the relative numbers of nematodes and so forth in a particular gram of soil, and you can extrapolate that out and start coming up with the amount of mass of weight of bacteria, fungi, flagellates, amoeba, ciliates, toads in an acre. And so I took those numbers and I tried to be conservative here, but in conservative by the sense that I just calculated this for the top 6 inches of soil in a corn trial that I did in Mexico in 2009. And it's actually posted on my website, not this particular information, but a bit about the corn trial if people want to look and see what the yields were, because the yields were pretty dramatic.
And that's soildoctor.org.
Soildoctor.org, yeah. And so I was just fascinated, from a carbon standpoint to say, okay, I know I'm increasing the number of microbes in my soil because I'm doing testing through the lab. And so what I did, and this was in May of 2009, I said, okay, I'm going to send a soil sample up to the lab, and I'm going to test how much bacteria, fungi, protozoa, nematodes, et cetera, I have in my soil. And then I also did another test in September of that same season in 2009. And I did another one in November, but I focused here on the May and September. And so I went, and then what I did is now I could calculate out how much microbes, pounds, I had in that top 6 inches of an acre of my soil. And and then I converted that further into CO2, into carbon dioxide, how much is actually embedded in the bodies of those microbes. So when I started out in May, I had 308 pounds per acre in the microbes of CO2 in the microbial bodies of that system. And in September, I went up to 1,121 pounds.
That is amazing.
That's not the humus or the other thing, as we talk about the organic material. That's the living bodies of the microbes. And now to boot, those guys are sitting in that soil working with the plants to create more of the, let's call it, non-living organic material in that soil, right? So it's not just that they contain the carbon, they are the carbon soil organic material makers.
Yeah, when I thought of carbon sequestration in the soil, I think of the plants pulling it out. Mm-hmm. But you're bringing in this whole other role of the microbial life in the soil.
Well, we got to think like, how does a plant go from what it looks like, which is a plant, a leaf, a twig, a branch, a root? How does it go from that state into soil, into the soil organic matter? It goes through a decomposition process. And who does that? The rulers of the world, microbes.
It's true. I teach environmental ed to kids. In some of the classes, I call them the decomposer superheroes. Because they are. And I said, just, think without them, the earth would be littered with dead things. And that gets the kids. They're like, ew.
Yeah, exactly. Exactly.
So these microorganisms hold the carbon in their bodies, and I kind of asked this before, but when they die, is the carbon released, or do you just keep building the population so the new populations pull it back in?
Well, there's a lot of, let's call them pathways of that carbon, and maybe let's sort of imagine for a moment, first of all, let's look at a bacterium, a little individual bacterium cell. There seems to be no evidence that it dies on its own. There's no, typical lifespan of a bacteria. It depends on who eats it and if an extreme environmental event comes along and kills it. It gets, let's say, dry really fast or cold really fast or a fire or something like that. So it's just going to sit there doing its thing until somebody or something comes along and kills it. And now, which is a really interesting thought to think about, actually. So now, okay, so when it dies, right? What is really going to happen? Somebody's going to eat it. Okay, even if it dies in a, let's say, or if it's a fire, I suppose it's going to be burnt off. But let's imagine that it gets eaten in most cases. And there's a kind of an interesting thing. I think a lot of people probably know about, if I'm making compost, one of the things, I don't quite do it, but one of the things, I do it, but I'm just saying typically people only say there's a carbon-nitrogen ratio that always gets talked about in compost. You should have a certain amount of carbon in your compost pile versus nitrogen. Typically, it's somewhere between 25 and 35 carbon units per one nitrogen. And the reason why I have a range there is the more carbon you have in the pile, the more fungal it will probably turn out to be down the road. And the same holds true for any organic living organism, you and I included. We have a certain amount of carbon units in our body versus nitrogen. And bacteria, fungi, protozoa, trees, corn, everything, all these carbon-based organic material organisms have some kind of a ratio. And so if we look at this bacteria that just gets eaten, and usually that bacteria is going to be eaten by a protozoa. Usually they're the big bacteria eaters in our soils, and those are mainly flagellates and amoeba, and there's also something else called a ciliate. And so let's look at a flagellate for a moment. Now, a flagellate has, as a carbon, on average, a carbon to nitrogen ratio of 30 units of carbon to one nitrogen. A bacteria, on the other hand, a single bacterium, has 5 units of carbon to one nitrogen. The highest organism in the world in terms of nitrogen. That's why I said they're little bags of fertilizer. Now, if I'm a flagellate and what I need to do is replenish my carbon intake, then let's think for a moment. I need to eat. I got 30 units of carbon, and I need to replenish 30 units of carbon, and a bacterium has 5, each of them. I'm going to eat 6 bacterium. That gives me my 30 units of carbon. But I only needed 1 unit of nitrogen. Now I just ate 6 bacterium, each having 1 unit of nitrogen, and I only needed 1 of them. So what comes out my tail end is my protozoa manure, my flagellate manure, which is filled with all that nitrogen.
Which the plants need, right?
That's and it's soluble. It is microscopic manure, right? Which is soluble and plant available. When it's in the body of the bacterium, Like you and I mean, we could potentially, we will potentially become food for some kind of plant. The carbon and nitrogen in us will someday be flowing through the leaves of a plant, okay? But to get us from no plants can come along and eat us right now. We are not soluble. We're not plant available. Somebody needs to eat us, right? Just like those bacterium, in order to make the nutrients encased in our skin available for the plants to take up.
It's kind of like in the worm bin, how my friend was saying that the bacteria is what's actually making the food available for the decomposers. Is that true?
Well, the bacteria are the decomposers.
Right, right. But he was saying that when the worms are actually eating bacteria more than food in the worm bin. Do you agree with that?
Exactly. Worms do not have digestive enzymes. They cannot break up the organic material that we put into those worm bins. They don't have the ability to break those molecules up with enzymes. The ones who have the enzymes are the bacteria, the fungi. That's decomposition. Decomposition is I take some enzymes, I spit them out on this thing, and it breaks up the molecule, and then I can pull energy from it. That's basically it. And now what the worms have is they have right inside their initial mouth, they have a crop-like structure. Just think of like a crop in a bird. Puts a little tiny bit of sand in there. And what they do is they go and scoop off the surface of the organic material, all the microbes that are growing there and decomposing, pull them into their crop and crush them and release cytoplasm, which they then absorb. So compost, for me, it doesn't matter if it's a hot compost pile, a vermicomposting system, a static compost pile, they're all the same thing. They're microbial processes. And the rule that I had before, which is keep it aerobic and decide whether you need fungi or bacterial dominated, same thing for worm compost. Most people produce bacterial dominated worm compost because they're feeding primarily kitchen scraps, manures, things like that, which have lots of nitrogen in them. Where's the wood? Take all your, paper products that don't have toxic chemicals and toss them in there, shred it up with a little bit of water to make them moist, and try to go 50-50. Get 50% of your worm bin as papery products. It will take longer to break down, but at the end of the day, you'll have a more fungal worm casting.
I love that because I have 4 worm bins.
Yeah, feed them paper.
So, Doug, what's something that a gardener could do at home to help improve their soil fertility and grow microbes at the same time?
Well, I think the first step towards sustainability in any garden or farming system, the first step, and Elaine talks about this quite a bit, the first step is no-till or low-till. That discussion we had earlier, which is just imagine it's like a blender blade moving through the soil. It's not just sand, silt, and clays that we're chewing up, right? We're killing microbes, and in particular what we're doing is killing the fungi in the soil because of the nature of the way that they have their structure of their bodies as tubes and so forth versus bacteria, which are really just tiny little small little dots, right? So the first thing to think about is how can I, let's say in my backyard garden, how can I garden in a way that doesn't require me to till? Or how can I garden in a way that doesn't require me to disturb the soil as much as I currently am, right? And that's everything from how you plant to how you would mulch to how you would harvest even, right? Do I leave some biomass behind? Do I leave the root structures behind? All those things. So trying to minimize soil disturbance, I think, is the number one first step anybody, whether it's a home gardener or a big, in a big industrial farm, needs to do. And that doesn't require money.
So no-till is really important for home gardeners.
Yeah. Yes. And I think I'm not dogmatic about these things. And remember the continuum that I described too. If you happen to be a fortunate person living, in an old growth forest in Oregon and you want to grow broccoli, you should go out there and beat the hell out of your soil. Really, because you're going to have a hard time growing broccoli in that fungi-dominated soil. But if you beat it up, a little patch, I'm talking a little patch, then you're going to have a better chance at growing that broccoli. So, it's not what I want people to do is start understanding the system, that I'm describing, so that they can use their own set of microbial soil food web glasses to analyze their conditions, right? What would naturally grow in your backyard garden if you walked away from it, right? Would it be a weedy system? Would it be tree sprouting? These are things that will give you an indication, a very approximate one, but an indication of the bacteria-fungi ratio in that soil, right? Now, most of the time, if people have been tilling and they've been adding salt fertilizers, and I'm sure that there's a number of folks that are listening to this podcast who are saying, well, I put inorganic stuff out. Okay, well, do you put manures out? And we just had a conversation. Who likes to eat manure? High nitrogen bacteria, right? So you might want to try to get a little bit more carbon into that. Maybe you want to take that manure and build really good aerobic compost in there. If you're having a hard time growing strawberries, maybe it's because that soil that you have you've been feeding a lot of bacteria in it, right? You might be reducing your tillage, but at the same time you're just providing more and more food for the bacteria versus the fungi. And I mentioned the humic acid, that if people want to buy a product, humic acid, but you don't have to buy products. I mean, one of the things I do when I work with some very, very extreme poverty, we call them campesinos, people that work and live in the rural countryside here in Mexico. It's like, how do we find different organic materials that exist within these communities and identify whether they're a bacterial or fungal food? Turns out that if you take fish heads and guts and all that, so you fillet the fish. So what you're looking for are the guts and the head and the bones. Grind them up in a blender. I mean, really grind them up. And throw in about 5 to 10% of a kiwi or papaya. There's enzymes in those kiwi or papaya. Let it sit for half an hour. Those enzymes are going to break down the oils and some of the proteins in that fish carcass to the point where it's a hydrolysate. It's a perfect fungi food. If you let it sit for 2 days, it breaks down further and becomes more of a perfect bacterial food. Okay? That's called an emulsion. So you want a hydrolysate, which is a very quick and easy, blend it up, kiwi, papaya, go to the fish store, get those guts, right? And then strain it so that you can put it into a liquid form and get it out with whatever sprayer you have. That's a fungal food into your system. So these are little kind of tricks that people can start thinking, who am I feeding in my gardens? What am I putting down, and what does it feed? Does it feed bacteria, fungi? Am I tilling? That's going to slice and dice mainly my fungi and make it more bacterial. So these are two kind of initial things that people can do to start increasing the fertility, let's say, of their soil, the microbes in their gardens, and bringing them into a bit more of a balance, most likely, which will be an equal bacteria-fungi ratio. And again, if you happen to be that fortunate soul who lives up in the old-growth forest in Oregon and wants to plant broccoli, you're going to beat the hell out of that soil, right? So I want to keep using that as it depends, right?
Where you are.
It depends on where you are. And, what would naturally grow there? If you walked away for 5 years, what would be there in 5 years? And that will give you an approximate idea of what the bacteria-to-fungi ratio is.
That's a great exercise to do. Wherever you are.
Around.
Yeah.
Yeah. Look at disturbed soils along roads. Look at any place, construction sites. What pops out of the soil? It's usually going to be a pioneering weedy species, and that soil is going to have tons of different seeds in it. It's going to have even maybe some perennials, but the conditions are not right for those more, let's call them, more advanced on the succession continuum. The conditions are not right for those seeds to take off, but they're right for those weeds to take off. And those conditions are microbial.
Doug, if you could share with our listeners how they can contact you and any courses or classes you'll be teaching.
An easy way to contact me is to go to my website, which is soildoctor.org, O-R-G, and you'll see on my website that there's contact information, email, telephone. I have a Mexico line and a U.S. line. And there's also a section on the website right on the front page which allows you to register for my mail list. And I promise here, I'm cutting myself, there's blood dripping, that I will never give out email addresses. Those are only used very infrequently for me to send out notices about workshops, where they're going to be held, as well as I'm in the process of producing a number of short little let's call them mini documentaries that I'll be posting on my website about different case studies and testimonials and so forth. So I like to just notify people of that. Might be once every couple of months that something goes out from me. So that's a way to sort of contact me and to keep in contact. And in terms of workshops, this is the time of the year when everything's sort of getting planned for 2011. And right now, I don't have definitive workshops scheduled in terms of dates, but I have a number that are being pinned down right now. There's one actually that's hopefully going to be in your area, Jill, sometime in 2011 in the Santa Barbara, California area. There's probably going to be another one right now. We're looking at Albuquerque, and that will probably be mid-March to end of March, so it'll be early spring. In Albuquerque, New Mexico. There may be another one in Colorado sometime around that time. There's some talks in Texas right now, San Antonio, Rio Grande Valley way, which is still very initial. And then for folks who want an adventure, there's probably going to be a course that I'm going to teach down here in San Miguel in Mexico, probably about 6 months into 2011 here in my hometown. And then there's a bunch in Canada, but those are just early right now. And I would say to anyone out there, hey, if you're interested in having me do a workshop, please just contact me and let's start up a conversation and see what we might think is possible.
Well, thank you so much, Doug Weatherbee. It's been wonderful to talk with you today, and I look forward to hearing more about you as your travels and your work takes you deeper and deeper into the world of soil.
No pun intended.
Yeah.
It's a real pleasure for me, Jill. Really a pleasure.
You've been listening to a Sustainable World Radio podcast. For more information or to hear our other podcasts or interviews, visit www.sustainableworldradio.com. Sustainable World Radio is produced by Jill Cloutier. Music by Dana Lyons. Thanks for listening.